Welcome to Spanning Tree, a configuration adventure. This guide gives you information about Spanning Tree Protocol. How a device or port becomes the root device or root port. If all devices in a network are enabled with default spanning tree settings, the device with the lowest MAC address becomes the root device. Spanning tree topology. Device A is elected as the root device because the device priority of all the devices is set to the default 32,768, and device A has the lowest MAC address. However, because of traffic patterns, number of forwarding interfaces, or link types, device A might not be the ideal root device. By increasing the priority of the ideal device so that it becomes the root device, you force a spanning tree recalculation to form a new topology with the ideal device as the root. When the spanning tree topology is calculated based on default parameters, the path between source and destination end stations in a switched network might not be ideal. For instance, connecting higher speed links to an interface that has a higher number than the root port can cause a root port change. The goal is to make the fastest link the root port. For example, assume that one port on device B is a gigabit Ethernet link and that another port on device B is the root port. Network traffic might be more efficient over the gigabit Ethernet link. By changing the spanning tree port priority on the gigabit Ethernet port to a higher priority than the root port, the gigabit Ethernet port becomes the new root port. Spanning tree and redundant connectivity. You can create a redundant backbone with spanning tree by connecting two device interfaces to another device or to two different devices. Spanning tree automatically disables one interface but enables it if the other one fails. If one link is high speed and the other is low speed, a low speed link is always disabled. If the speeds are the same, the port priority and port ID are added together, and spanning tree disables the link with the highest value. You can also create redundant links between devices by using Ether channel groups. Spanning tree address management. IEEE 802.1d specifies 17 multicast addresses, ranging from hex 00 to hex 10, to be used by different bridge protocols. These addresses are static addresses that cannot be removed. Regardless of the spanning tree state, each device in the stack receives but does not forward packets destined for addresses between hex 00 and hex 0f. If spanning tree is enabled, the CPU on the device or on each device in the stack receives packets destined for hex 00 and hex 10. If spanning tree is disabled, the device or each device in the stack forwards those packets as unknown multicast addresses. Accelerated aging to retain connectivity. The default for aging dynamic addresses is 5 minutes, the default setting of the MAC address table aging time. However, a spanning tree reconfiguration can cause many station locations to change. Because these stations could be unreachable for 5 minutes or more during a reconfiguration, the address aging time is accelerated so that station addresses can be dropped from the address table and then relearned. The accelerated aging is the same as the forward delay parameter value when the spanning tree reconfigures. Spanning tree, VLAN 100, forward time, 180, global configuration command. Because each VLAN is a separate spanning tree instance, the device accelerates aging on a per VLAN basis. A spanning tree reconfiguration on one VLAN can cause the dynamic addresses learned on that VLAN to be subject to accelerated aging. Dynamic addresses on other VLANs can be unaffected and remain subject to the aging interval entered for the device. Most devices supports these spanning tree modes and protocols. PVST+. This spanning tree mode is based on the IEEE 802.1d standard and Cisco proprietary extensions. The PVST+ runs on each VLAN on the device up to the maximum supported, ensuring that each has a loop-free path through the network. The PVST+ provides Layer 2 load balancing for the VLAN on which it runs. You can create different logical topologies by using the VLANs on your network to ensure that all of your links are used but that no one link is oversubscribed. Each instance of PVST+ on a VLAN has a single root device. This root device propagates the spanning tree information associated with that VLAN to all other devices in the network. Because each device has the same information about the network, this process ensures that the network topology is maintained. Rapid PVST+. Rapid PVST+ is the default STP mode on your device. This spanning tree mode is the same as PVST+, except that it uses a rapid convergence based on the IEEE 802.1W standard. To provide rapid convergence, the rapid PVST+ immediately deletes dynamically learned MAC address entries on a per-port basis upon receiving a topology change. By contrast, PVST+ uses a short aging time for dynamically learned MAC address entries. Rapid PVST+ uses the same configuration as PVST+, except where noted, and the device needs only minimal extra configuration. The benefit of Rapid PVST+ is that you can migrate a large PVST+ install base to Rapid PVST+ without having to learn the complexities of the multiple spanning tree protocol, MSTP, configuration, and without having to re-provision your network. In Rapid PVST+ mode, each VLAN runs its own spanning tree instance up to the maximum supported. MSTP. This spanning tree mode is based on the IEEE 802.1 standard. You can map multiple VLANs to the same spanning tree instance, which reduces the number of spanning tree instances required to support a large number of VLANs. The MSTP runs on top of the RSTP, based on IEEE 802.1W, which provides for rapid convergence of the spanning tree by eliminating the forward delay and by quickly transitioning root ports and designated ports to the forwarding state. In a device stack, the cross-stack rapid transition, CSRT, feature performs the same function as RSTP. You cannot run MSTP without RSTP or CSRT. Spanning tree interoperability and backward compatibility. In a mixed MSTP and PVST+ network, the common spanning tree, CST, root must be inside the MST backbone, and a PVST+ device cannot connect to multiple MST regions. When a network contains devices running Rapid PVST+ and devices running PVST+, we recommend that the Rapid PVST+ devices and PVST+ devices be configured for different spanning tree instances. In the Rapid PVST+ spanning tree instances, the root device must be a Rapid PVST+ device. In the PVST+ instances, the root device must be a PVST+ device. The PVST+ devices should be at the edge of the network. All stack members run the same version of spanning tree. STP and 802.1Q trunks. The 802.1Q standard for VLAN trunks imposes some limitations on the spanning tree strategy for a network. The standard requires only one spanning tree instance for all VLANs allowed on the trunks. However, in a network of Cisco devices connected through 802.1Q trunks, the devices maintain one spanning tree instance for each VLAN allowed on the trunks. This marks the end of Part 3.